All right, 4-6 inequalities in one triangle. Today's date is the 29th. Theorem. Okay. Now, I'm going to use letters to label these sides, but for example, this side I'm pointing to here, I could call it what? 2 letters? BC. And this side would be called AC, and this side would be called AB. So we will AB or BA. So we're going to talk about it that way, but I'm also going to use lowercase letters because many times in mathematics we label the angles with uppercase and the sides with lowercase. And the reason I want to do that today is to show you how they match up. So we're going to talk about angles and opposite sides today. So if I am pointing at angle A, which side is opposite? Is that AC, AB, or BC? Opposite angle A would be this side here, so I'm going to call that lowercase a. Can you guys see that? Does that make sense? Now, if you look at angle A, AB is connected to angle A, AC is connected to angle A. The only side opposite is side BC. Kids will say, oh, well, angle B, but I'm not talking about opposite angles, I'm talking about opposite sides. Angle, opposite sides. Okay, with that being said, what angle or what side is opposite angle B? AB or AC? AC. So I'm going to put that as lowercase b. And last, angle C. Which side is opposite angle C? AB. So I'm going to put a lowercase c. Lowercase a, lowercase b, lowercase c. And you want to get used to looking at the opposite angle, opposite side business. Now, the theorem states if side A is greater than side C, if side A is greater than side C, then the same is true regarding its opposite side. Then, or its opposite angle, I apologize, then the measure of angle A will be greater than the measure of angle C. Write that down and I will explain again. Put your phones away, please. Okay, are we ready? If side A is larger than side C, then that means angle A is larger than angle C. Does that make sense? Now, I'm hoping it does make sense because if A is longer than C, then do you agree angle A has to open up wider to adjust to that side? And if C is smaller, then this angle is not going to open up as wide to connect to that side there. Does that make sense? Yes? All right. I'm going to put here that the converse is also true. And what does that mean? That if a side or an angle, if angle A is bigger than angle C, then side A is bigger than side C. So it does go both ways. All right, questions? Okay. List the sides from shortest to longest.
Is this an example?
Yes. And I should have put that here, examples. List the sides from shortest to longest. All right. Number 1. $90 and $30, and I'm going to call this U T V. Okay, so I'm not putting any lower cases here, so we are going to use segments like TV, UV, UT. Now, did I give you all of the angles? There's one missing. Do you have enough information if I've given you these two? Right, I gave you two, 30 and what? 90. Oh, good. So go ahead and find that angle T. I want you to do that right now.
Is that last one V?
This is T, U, and V.
Does it ever say 30 or
30 degrees. All right, anybody have that missing angle? 60. Can anybody tell us how you got it? 90 plus 30, subtract from 180? Yes? Or if you said an equation, you can do like 90 plus 30 plus x equals 180 and solve for x. Yes? All right, we want to list from shortest to longest. Okay, shortest, then I look on the insides. Which one is my smallest angle? 30. So I look at the 30 and I look for its opposite sides. I did not put like a lowercase letter, but we can still look for its opposite side. So can anybody tell me using two letters what side is opposite the 30? What would you call that side? TU. Comma. You guys see that? What is your medium size angle? 60. And you draw across, or your eyes look across, what side, using the two letters, is opposite the 60? UV. And last, what is the largest angle? The angle is 90, the angle U, and you go across the U, and what side is opposite the U? TV. Okay, questions on that one? No? Okay. I am going to have you try number 2. Triangle DEF. The measure of angle D equals 20 degrees. The measure of angle E equals 120 degrees. And the measure of angle F equals 40 degrees. Mm-hmm. All right. Can you tell just by looking what the answer is? What the answers are, like in which order they go? Anybody give me a suggestion on what we could and should and could do? Yes? Draw the triangle. Good. Ahmad? All right. So I heard for Marita to draw a picture, a triangle, and that is correct. That's what I'm going to do now. Thank you. Okay. And I'm going to label it DEF. And D is 20 degrees. E is 120 degrees. Oh, I lied. E is 120 and D is what? 20. Thank you. And F is 40. Okay. So can we do the same thing we did on the last one? Yes? So it's still shortest to longest. So let's go to the shortest. If I'm dealing with shortest side, I'm looking for the smallest angle. Which angle here is the smallest? 20. So DF is not opposite because it's next to it. DE is not opposite, again, it's connected to it. And which side is opposite the 20? EF. Please stop the talking, gentlemen. Comma. What is my medium side, or angle, sorry, what's my medium angle measure? 40 degrees? Yes? Thomas, can you tell me what side is opposite angle F? What two letters make up the side that are opposite? Let me show you like that. What two letters? ED. ED, if you put DE, is that okay? Yes. All right, and lastly is what angle? 120. Angel, can you tell me what side is opposite the 120? DF. DF, FD, up to you. All right, any questions on how to work these out? Easy enough? All right. Next piece I'm going to do is list the angles from smallest to largest. All right, list the angles from smallest to largest. All right, so this is pretty much the converse now. So L, K, M, 2.7, 4.3, 5.8. And this I apologize, is not the converse. This was the converse here with these two. So with this one, we're going to just go the opposite way from what we did with the first two. If we're looking for smallest and largest angles, I look at their sides. So which side is the smallest? LK, the 2.7? Yeah. So I look at LK's opposite angle. Is K its opposite angle? Is L its opposite angle? Is angle M the opposite angle? Yes, so that is the smallest angle. Okay, next. What is my second or medium side length? 4.3. And we're looking for the angle that is opposite. So I want you to look at it, see if you can figure it out. And what angle is it? Angle L. And lastly, what's the longest or the longest side? 5.8. And what angle is opposite? Angle K. Questions? None? Okay, number 2. Triangle ABC.
Do we have a question like this on the test? Are these all test questions?
Yes. Triangle ABC, where AB equals 8, comma, BC equals 5, and CA equals 7. All right. Is this another one like our number 2 on the other page where we should draw a triangle? Yes. Sign out and hustle. All right, I'm going to have you guys try this one on your own. Draw your picture first. Draw your picture first. Yeah.
Does it matter like what kind of triangle you draw?
No, good question. And he asked, does it matter which kind of triangle we draw? It does not, as long as you label it ABC. So your triangle maybe look different from everyone else's, maybe look different from mine, but as long as you label AB8, BC5, and CA7, we should all end up with the same answer. So that's why I want you to try it on your own first. All right. Are we ready? Did you guys? Yes. Now, take a look at your neighbor's paper. See if your triangles look different or the same. Different?
Yes, very different.
Okay. Go ahead.
I'll just grab it.
This right there, and I can stand. Okay, so I'm going to draw my triangle.
Wow, that's perfect.
A, B, C. Anybody look the same as mine? Anybody look different?
Mine goes.
Like flipped around, rotated, reflected? Okay. So, if I have it like this, according to my information, AB is 8. This is AB for me. BC is 5. This is my BC. And CA is 7. Now, if your triangle looked different, do your numbers look different? Like not different, but in different places. Yeah, I'm going to show you mine, my old notebook really quick. See how I have it like 7, 8, 5? Oh, you can't see it, sorry. 7, 8, 5. Are those in different positions from my 8, 5, 7? Yes. But just like yours, if it looks different, as long as you put your numbers in the correct spot, it should not matter. So let's see if we can get the answer. And I lost my pencil. There it is, I see it. Okay, are we ready? What is the smallest side?
BC.
BC, and what side which angle corresponds with the 5? Angle A, comma, what is my medium side? AC, good job, and that matches with which angle? B. And my largest side is? A. Okay, you gave me the angle. My largest side is AB, which matches with angle C. Okay, those of you that had triangles looking different than mine, did you still get the same answer? Yes. All right, so I'm going to show you this one, my old notebook. Same answers, ABC, even though the picture looks different. So it doesn't matter as long as you are labeling it properly. Questions? No questions? All right, I am going to give you the triangle inequality theorem. Triangle inequality theorem. It's the same thing.
Oh, this.
Oh, you know what? No, it's not. Let's flip it around. Okay. Triangle inequality theorem states that if I have a triangle with angle, sides. Yes, I will. With sides A, B, C. Notice I use lowercase because I'm talking about sides and not angles. The theorem states in any triangle, the sum of any two sides will be greater than the third. Has to be greater than. Not greater than equal to, but greater than. So the sum of these two sides will always be greater than its third side. The sum of C and B, that's these two sides, will always be greater than its third side. What would be the third side if I'm adding these two up? Side A, right? I add up C and B greater than A. I did A and B is greater than C. What's the last two I have to add up? Good. A plus C would be greater than B. All right. And this is a theorem you will need to know for the quiz, the test. Oh, and make note, you guys know there's a quiz on Monday. It's on your assignment sheet.
Oh, nice. Wait, was it on?
It's on there.
No, what's on?
Oh, that mid-review that you guys had for homework, all of that stuff. And maybe some of these, I haven't decided yet. Monday, because I want you to use it to study. Okay, I'm going to move on with examples. Are you guys ready? Yeah?
I can just take a picture of that.
Okay. Who said that? I love math.
I love math.
I love it.
I like math, but which means I love it.
Okay.
I just didn't want to say that.
All right.
I am math.
I am math. I didn't choose the math slide. All right. Can a triangle, am I in screen? Yes. Can a triangle have sides with the given lengths? Okay. Number 1, 2 meters, 6 meters, and 9 meters. Okay. So here's a type of work I want. Do you have an answer for me?
Oh, no.
Okay. Bless you.
Bless
Here's
you.
the type of work I want to see. I do not care if you, oh, it's always I can do it in my head. I keep telling you that. You need to show your work. Put your cell phones away. I keep telling you guys this. Put them away, away, away. All right. I'm just going to go and I'm going to add the first two together first. 2 plus 6 must be greater than 9.
Yes.
What's 2 plus 6?
8. That's 8 must be greater than.
And is 8 greater than 9?
No.
No. So is this answer yes or no? This is a no. It did not work. Why? Because the sum of any two sides must be greater than the third, and 2 plus 6 is not bigger than 9. Again, I'll have kids like, oh, I just did it in my head. You need to show me this.
What if it equals 9?
Good question. What if it equaled 9? What if I had 3 plus 6 is 9? Would it be yes or still be no?
No, it's not greater.
Because it's not,
Has to be greater.
it's not equal to, it's just greater than. You guys are correct. All right.
Why'd you put that X right there next to it?
Oh, that was just a no. That was my no, because I do check marks later. Oh, I'm sorry. Number 2, 4, 6, 9. All right. So I'm going to start with the first two. You guys are listening. 4 plus 6 must be greater than 9. What's 4 plus 6?
10.
Is that greater than 9? Check mark. Now, that doesn't mean I'm done. I have to check the next one. I'm going to go to the last two, 6 and 9. Is 6 plus 9 greater than, what's the third side if I'm adding these two? 4. Is 6 plus 9 greater than 4? Check. What's the last two sides I have to add together?
4 plus 9.
The first and the last is 4 plus 9. Will that be larger than 6? If they're all yes, what would your answer be?
Yes.
Yes. Got it? Okay. Now, one more time. Do you need to show this work on your homework, your quizzes, and your tests?
Yes, Miss Dora.
Thank you. Yes.
Oh.
Can you do one more of those?
I am.
So if there's, there's only one no, it's.
Automatically no. Good question. I'll talk more about that. Let me answer this question
So like,
first.
it doesn't matter what number you use.
Can we go over
as long as,
one
like,
question
the
on the
left
weekend?
can be divided into
As long as the sum of any two is greater than the one you're not adding. These two greater than 9, these two greater than 4, these two greater than 6. As long as the sum of any two of these numbers is greater than the third. Now, guys, I do need you listening. Listening. Sometimes you'll get lucky and you'll find out that it's no right away. Sometimes you don't know until the end. Once you hit a no, do you have to keep checking?
No.
No. So if I got yes, no, I could stop there and say no. Because if it was yes, yes, no, it doesn't matter. As long as one of them is no, the whole answer is no. Got it? Okay. So let's try another one. Number 3. 2, 5, 3. And I want us to go in order. 2 plus 5 must be greater than 3. And we're checking, is that true? Is 2 plus 5 bigger than 3? Yes. I'm going to do the first, the middle, and the last. 5 plus 3. What is that? 8. Is that bigger than the 2? Yep. And what's my last inequality going to look like? 2 plus
3.
must be greater than 5. And I forgot to put my check marks here. Yes and yes. And does that last one work? Yes or no?
No.
No. So that's where I would put the X. That's a no. Why does it not work?
It's equal.
Because it's equal, not greater, and there is no equal bar. So what's this answer, yes or no?
No.
No.
So that means that it can't be a triangle?
It cannot be a triangle. You cannot construct a triangle with side lengths 2, 5, and 3. 2 inches, 5 inches, 3 inches. 2 meters, 5 meters, 3 meters. If you had sticks with these lengths, they would not construct. Like you've had one like this, you'll have one like this, and this next one wouldn't ever reach. It wouldn't be long enough. That's what's going to happen.
Well, then why don't?
So you'll have your 2, your 5, and your 3 wouldn't ever make it.
Give me a ruler. Give me a ruler.
All right. Number 4. The lengths of, what was that? It doesn't matter. It could be any. 4 inches, 6 inches, 9 inches will work. 4 centimeters, 6 centimeters, 9 centimeters would work. 4 miles, 6 miles, 9 miles would work. 2 meters, 5 meters, 3 meters would not work. 2 centimeters, 5 centimeters, 3 centimeters. Did it work?
No.
Does not work. Okay.
I'm trying to see if it works.
All right.
I had a test. I didn't.
All right. The lengths of 2 sides, thank you, of a triangle, I didn't write that down, of a triangle are given. Period. Describe the possible lengths. Describe the possible lengths for the third side. All right, 4 and 7. That's all I'm giving you. What's the possible, what are some numbers? Can we just throw numbers out there? Give me a random number.
3, 2, 6.
Okay, I heard 3, 2, 6. So I'm gonna try 3 first. Okay, I'll try 4. Let's check. What's 4? Wait. What's 4 plus 7?
8.
4 plus 7 is 11. Is that bigger than 3? Yes. What's 7 plus 3?
10.
Is that bigger than 4?
Yes.
And what's 4 plus 3?
7.
Is that bigger than 7? So would 3 work or not work? No. Okay, I heard 4. Let's try 4.
But we already have, we can use.
You can use it, yes, because that'll be an isosceles triangle. Good question. Please stop. His question was, can we use a 4 if we already have one? Yes, because it could be an isosceles, even an equilateral triangle. All right, quickly. 4 plus 7, does that work?
Yes.
7 plus 4, does that work?
Yes.
And 4 plus 4, does that work?
Yes.
Okay, so 4 is a yes. Let's try another number.
5.
5. Check it. 4 plus 7, does it work?
Yes.
7 plus 5.
Yes.
And 4 plus 5.
Yes.
Give me a bigger number.
21. 8.
21. 4 plus 7. Is it going to work?
No.
No. Okay, now, guys, do you agree there's a few numbers that work and a lot of numbers that don't work?
Yeah.
Okay, so how do you figure them out? I'm going to give you the
Try
mathematical
10.5.
tool to figure it out every single time. You read this. A number is less than x and x is less than a different number. So like 2 is less than x and x is less than 5. Something like that. Have you guys seen these inequalities before like this?
Yeah.
Where x is sandwiched in the middle? Yes? Gentlemen, it's not working. I'm telling you guys that right now. Mwah.
They're not even talking.
All right.
I really can't.
Hey. All right, listening. Howdy. Up here. Oh my goodness, I have ears. I can hear, Thomas. Nobody is snitching.
Yeah, you're talking about me. Sorry,
Okay.
you're talking.
Guys.
Oh.
All right. I am recording. So we are going to pipe down and get back to our lesson.
Alright, you guys. I'm gonna teach you the lesson. Alright, we're gonna switch up the lessons real quick. So we're gonna be talking about.
All right. Guys, back to our lesson. Whew. The shortcut, so we're not guessing all kinds of numbers, is you take these two and you subtract for this section. 7 minus 4. 7 minus 4 is what? 3. And then in this section we do 7 plus 4. What's 7 plus 4? That means our range of numbers will range between, it has to be bigger than 3 and smaller than 11. Why did 3 not work? There's no equal bar, right? It has to be greater than 3, not equal to 3. So did 4 and 5 work, and are those numbers between 3 and 11? Yes. Would 11 work? No. And what was the other big number we tried? 21? Would 21 work? No. So this is how you do it. 3 is less than x, and x is less than 11. Got it? I'm going to give you one to try on your own. Number 5. 20 and 35. All right, what do we do for the first one? Add or subtract?
Subtract.
And what's 35 take away 20? 15. And what do we do for the last one? Add 20 plus 35 is what? 55. So my list of sides that would work have to be between bigger than 15 and smaller than 55. Would 60 work?
No.
Would 55 work?
No.
30?
Yes.
Yes. 10?
No.
No. All right. Make sense? Now, I will tell you this. There are 2 more problems I need to do, but we do not have time. So we are stopping these 2 right here. We are stopping right now. And, listening, I'm going to get we're going to finish these notes on Monday. I'm going to get the packets out, and these 2 I want you to circle. You are not doing these tonight because we do not have the notes for those yet.